All right, we're going to deal with one more aspect of valves and just kind of notice how you would handle them in series. And there's two ways you can look at that, and we're going to show that they're both the same, work out the same. So suppose you had two valves. One had a valve constant of Ka, another Kb, and they each have their own particular pressure drops across them. Okay, so then you would have, let's just remember we have this equation here. Here's the valve equation. Omega equals K, the square root of delta P. All right, so we could square this. Omega squared divided by K squared would equal delta P. So I have two pressure drops, so we add them together, and each one would have then, because they each have the same flow, omega squared over Ka squared. Just applying this, divide the K over, and omega squared over Kb squared. And so if you factor out the omega, then you see here's these two valves, and they would have the following overall valve constant. Whatever this is, that's equal to 1 on Kc squared. Okay? Now, I want to take a moment just to take note of that, because it almost is like, wait a second, is this kind of weird adding in parallel? Or I mean series? No, it isn't. So let's see. Rc, here we have this new valve constant based on that, is 2 omega, the nominal omega, divided by this new Kc squared. All right, so that's 2 omega. But what is Kc squared? Well, it's this. So we'll substitute that in. Distribute this over, and we'll have 2 omega bar over Ka squared plus 2 omega bar over Kb squared, which is defined as Ra plus Rb. It's all the same. Now we'll just note to kind of complete our introduction here of for hydraulic systems, we can have two types of sources: constant flow, that'll be a waterfall, just constantly flowing in. And then you can have a pump, which is kind of like a voltage source. You may have some pressure coming in or none, and then it steps up the pressure. Okay, kind of like what a voltage source would do. It takes stuff perhaps at ground and then raises the voltage up to have things keep on going. So that completes the introduction side of hydraulic systems. And so now we're going to look at a couple of problems. And the good news is we're almost done with lecturing here. We'll talk to you soon. Bye-bye.